Hey everyone, thanks for coming to my talk. My name is Tjiam. Today I'm going to talk about how all raffles are scams and how to raffle the Ethereum way. Now, obviously, I'm not saying all raffles are scams. This is kind of a clickbait title, but you knew that already. My argument is that all off-chain raffles should be considered scams because inherently they're black boxes, right? They're intransparent, so they could tell you how they draw random numbers and how they shuffle them, but you can't really know for sure. You can't really verify it. The trust model is basically, trust me, bro, right? However, on-chain raffles, the way that we do them now, they're very inefficient, right? So for example, like if you're drawing like 100 winners on-chain, you're going to be spending like millions of gas. You're kind of scamming yourself, right? This is a technical talk. I'm going to be talking a bit about raffles, why raffles, and then I'll show you how to perform raffles on-chain with a novel algorithm, hopefully you've never seen before. And then there'll be like no excuse for not ever doing a raffle on-chain ever again, right? So what are raffles? When I'm talking about raffles, I'm saying we're picking X number of winners from N number of participants. And essentially, technically, that means that we are shuffling a list of participants, and then we pick the top X as winners, right? Why do we do raffles? Well, they're good for, if you remember during the NFT craze, we did allow lists to kind of solve the gas war problem, which kind of worked. They're also good for giveaways, so like for marketing, good marketing tool for brands and communities. But what's wrong with off-chain raffles? During the allow list, like NFT craze, there were allegations about insiders manipulating the allow list themselves, or even the results. For example, like this happened with like Premint and Moonbirds. There's many such cases. Basically, you need to trust the influencer that's doing the giveaway or the raffle, right? That they'll do the whole process fairly and distribute the prizes fairly. And it comes down to like a lack of transparency, verifiability, and immutability. Like they can rug you, right? They can decide just not to give you the prize at the end. However, they are cheap to run because you don't have to use the blockchain, right? Why on-chain raffles? Well, the blockchain gives us transparency. We all know that everything is public. All the logic, on all the actions, it's all public. Anybody can see it. Anybody can verify it. And we can use cryptography to enforce fairness. For example, we can use something like VRF to be able to verify that a random number was generated actually randomly. And we can use like RANDAO, which is also enforced by cryptography. And there's also trustlessness because we can use, given we use immutable contracts, a raffler can load a prize distribution contract and they can't decide to rug you, right, if the codes are deployed. And I believe that raffles are actually like one of the only use cases of blockchains where it like really makes sense to only use the blockchain. Because the properties of a decentralized blockchain network is actually extremely important to enable like the best form of a raffle. So why aren't people using on-chain raffles right now? Well, they're very inefficient. It requires storing participants in a big like storage array on-chain, which is gas heavy on Ethereum. And winners are drawn usually by using an algorithm called Fisher-Yates. And this has a few problems. So one of them is like the naive implementation of Fisher-Yates can introduce modulo bias. So that means that it's not so fair. Some people will have more chances to win than other people, depending, of course, on the parameters of the raffle. And it's very expensive in terms of gas. For every winner you want to pick, it increases linearly, right? So if you want to pick like 100 winners, it starts costing like millions of gas. 1,000 winners, like forget about it. Wouldn't even fit in the block, right? And the winners have to be picked in order. So it has to be done synchronously. You have to pick like the 10th prize claim winner has to wait for the 9th, has to wait for the 8th, etc., right? Now, to have a look at how it doesn't scale, the DevCon raffle, if you all remember, they had like an auction raffle for the tickets. They picked 80 winners on chain. It costed about 10 million gas, right? And Paradigm, they tried to optimize this. They did pretty good. So the Art Gobblers contract can pick 250 winners with about 7.6 million gas. But it's only like a minor improvement, right? It's only like 2 million gas improvement. There's other implementations of like this raffling, shuffling, Fisher-Yates algorithm. You can see it in the MeBits mint, and you can also see it in the ETHCC raffle that they did. Now, can we do better? I give you the lazy Merkle raffle. So this is a novel method of raffling that I hope you've never seen before. It's built on cryptography, and it requires 2 components: Merkle trees and stateless shuffles. So everybody knows what a Merkle tree here is, right? Everybody knows what a Merkle tree is? I'll go through it anyway. So Merkle roots can compress arbitrarily large lists into like a single hash, right? So you can have any list of any length, and it can just be compressed down to this single 32-byte hash. Merkle proofs can succinctly prove that a particular item is in the list, right? And the last thing about Merkle trees that we overlook most of the time is that Merkle proofs also prove the index of that item in the list. And that's important for the next step. So this is just a visualization of Merkle tree. So this is like a list of participants, and this is how it would look like as a Merkle tree. And if we wanted to prove that C is part of that list, then we would have this proof, right? And this proof includes the index. So it's 2 in this case. So the second component is the stateless shuffle, right? So I want you to forget about array-based shuffling. We don't deal with arrays. So stateless shuffles is an algorithm that can deterministically map bijectively, using a random seed, an original index to a shuffled index in the same domain without duplication. That may be pretty hard to understand, but it's actually used in Ethereum consensus. So there's the swap or not algorithm that can compute the validators that need to validate an epoch. And there's also something called the Feistel shuffle, which is what I'm going to be talking about. And so basically, once we have a random seed, we can lazily interact with the shuffled list, right? That's the important thing. This is a visualization of a stateless shuffle. So on the left, you have the original indices of the list. And you can see that these are the stateless functions, stateless shuffles. And every time you compute one, it outputs the shuffled index using some random seed, right? And it's a one-to-one mapping, so there's no repetition. Now, if we put them together, then what we have is each participant can generate a Merkle proof that includes an index, the original index, and then we can feed that index into the stateless shuffle function, and then we can say that if that shuffled index is less than the number of winners we want to pick, then they are a winner. And we can compute this very efficiently on chain. This is a visualization of the flow. So if we have the Merkle proof, and then we have the stateless shuffle, we can feed the index like so, and then we end up with this shuffled index 0, and then we can decide, is it less than the number of winners we want to pick? If yes, then the owner of that proof is the winner, is a winner, otherwise they're not a winner. And that's basically the algorithm. And now if we apply that to the DevCon auction raffle, we can actually reduce the gas required to draw from 9.7 million gas to only 60,000 gas. So you're no longer scamming yourself as a raffle holder, right? If you're curious about how that works, you can go to docs.ferry.dev. There's a bit of like a light paper there that explains the whole thing. You can see it here. So, in a nutshell, we can just store a Merkle root instead of the entire participants array if we want to do an on-chain raffle. And the cost of raffling is always constant for the raffler, right? It's better than the Fisher-Yates shuffle because it's instant. It doesn't require synchronous execution of the raffle draw. So any winner can claim their prize at any time after a random seed has been chosen. Yeah, and with this we can have very gas efficient, verifiable, and very scalable on-chain raffles. So some of the trade-offs, right? Because we're using Merkle proofs, Merkle roots, we don't store the actual data that's required to create those proofs on-chain. So there's no DA guarantee if you store it off-chain. It's basically like a Validium, right? But in the future, you could post this as a 4844 blob to the beacon chain, and it'll be very cheap. And then you have basically fully on-chain raffles. And yeah, we defer computation of the shuffling to the winner during the claim, and that's what makes it super cheap and efficient. It's only about a 4,000 gas overhead for someone who's claiming a prize. So what does this enable? Well, it enables portability of raffles, so you could do cross-domain raffles. For example, you can collect entries off-chain, and then you can just post a Merkle root to a raffle contract on Ethereum and distribute prizes on Ethereum. Or you can collect entries on Arbitrum Nova and bridge that Merkle root to Ethereum mainnet. Or you can execute the raffle on Ethereum with a Randao or something, and then you can bridge the Merkle root and the random seed to a prize distributed contract on Optimism, Arbitrum, wherever you want. It basically enables like efficient 100% end-to-end trustless raffles on Ethereum. And you can actually see it in action if you go to ferryraffles.com. It's live, it's on Arbitrum 1. It's pretty simple. You just put in a list of participants, and then it uses VRF to produce a raffle. And then it shows you how to create proofs for each winner to claim a prize. You can even consume the Merkle root on-chain if you write a prize distributor contract, and it can be like a fully on-chain raffle. We also experimented during ETH Denver with this fun thing. We collected entries on Arbitrum Nova, all sponsored transactions, and then we just bridged the Merkle root to Ethereum mainnet to distribute NFT prizes. So yeah, that's my talk. Thank you. Does anyone have any questions?
Yeah, if somebody have questions, just raise your hand. We will give you a microphone.
First of all, thank you for the presentation. I don't know. Can you hear me? Okay, yeah. All right. I have two questions. First of all, I remember, maybe I remember wrong, but I remember on-chain there is no true randomness. So far, the VRF, the Chainlink one, and the other options, it's all fake randomness. So in order for your algorithm to work, do you rely on fake or true randomness? The second question is, how exactly do you reduce the order of n to order of 1? That part I didn't quite understand. It sounds like it's a tremendous reduction of the amount of iteration that the algorithm has to go through. Then if you can expand a little bit on the second point as well. Thank you.
Sure. So the first question was, does it require real randomness? So I didn't talk about where you would source the randomness. That's still up to you to decide what source of randomness is enough for your case. If you want a verifiable source of randomness, you might use VRF, although it has liveness issues. You might use Randao, although it has bias issues, but there's always a trade-off, right? There's no real true source of verifiable random that's doesn't have any trade-offs, not yet anyway. Maybe with Randao plus VDF, but we're still pretty far from that. So does that answer your question? First question, yeah. Second question was, what was the second question? Yes. How did I reduce the gas consumption like by orders of magnitude? Yeah. So it's similar to if you imagine like an airdrop. How you would do an airdrop naively is you would just send like n times to all the participants, right? And that would be very expensive, right? Or you could just store a Merkle root containing all the people who could receive the airdrop, and then everybody can claim asynchronously. And that's how it works. So we defer the computation. We push some of that gas to the claimer of the prize, even though the overhead is very small. It's only 4,000 gas. So it's still a lot cheaper. You could still do the airdrop method with this, and it would still be orders of magnitude cheaper than doing the naive raffle. Question?
I didn't get why VRF is not true randomness right now.
So VRF is like true randomness, right? Because it's a signature. It's a deterministic signature. So the properties of the signature is that it must be uniformly distributed. Otherwise, it's like guessable, right? So it is like a good source of randomness. But there are problems with like liveness, right? So for example, it's very centralized. VRF is like one chain link node. If they choose to censor your VRF request, they can just not answer your VRF request, and then you can't do anything about it. You just have to request another one. Yeah. Yes, sir?
Friends, if you don't have any more questions, thank you for your attention.
Thanks, everyone.